Hi future doctors, welcome to the next class. We were discussing about fringe width and angular fringe width. Fringe width equation we got d lambda by d. On what factors this fringe width is going to be depending means what is lambda here? Wavelength of the light. What is capital D? Distance between slits and screen. Correct? So this is capital D. And distance between two slits is going to be small d. Lambda is wavelength of the light used. If wavelength increases, fringe width increases. So if we are using WebGR, so which color is having highest wavelength? Red color is having highest wavelength. Therefore, red color will be having more fringe width. So distance between screen and slits is going to be increases 2 times. What happens to fringe width? Distance between two slits is made half. What happens to fringe width? So those you people can do very easily. So beta is equal to d lambda by d. So beta dash is equal to d dash lambda dash by small d dash. So distance between screen and slits is doubled, d dash equal to 2d. Distance between two slits is half, d dash equal to d by 2. Same wavelength they used, therefore lambda dash equal to lambda. Then how we will write this formula means beta dash equal to, in place of d dash 2d, in place of lambda dash lambda, in place of d dash d by 2. So 4d lambda by d. So what is d lambda by d we got? Beta. Therefore, beta dash is equal to 4 beta. So, fringe width increases 4 times. So, like this they are going to ask next time. This entire apparatus, they immersed in liquid. They immersed in water, let us assume, or liquid. So, without changing the separation, without changing the distance between screen and slits, entire apparatus immersed in liquid or water means, then which is going to be changed means lambda. How lambda is going to be changed? So, initial one in air, d lambda air by d. So, let us assume we are shifting to water. Then capital D remains same, lambda in water. So, wavelength is going to be changed according to medium. So, in previous way optics we discussed, or refractive index definition we said. So, mu is equal to C by V. There we said. Now, what is the relation between lambda A, lambda in air, lambda in water? So, according to this definition, mu is equal to CV. So, C is velocity of light in vacuum, V is velocity of light in medium. So, mu lambda. So, mu lambda in water if you are taking refractive index of water. So, this is in vacuum lambda. What is not changing whenever medium is changing means frequency is not changing. Therefore, lambda in water is lambda by mu double. So, therefore, in place of this, we can write d by d is going to be lambda air by refractive index of water. So, d lambda a by d can be written as, so fringe within air by refractive index. So, refractive index in water is going to decrease. If they give liquid, so they will give refractive index of that liquid they are going to give. Next, another problem they may give on this equation means at same point, so one wavelength they are using, that is lambda 1. So here nth bright band or dark band it is going to be forming. Did you remember formula for nth bright band and dark band? Bright band means nd lambda by small d. Dark band means 2n minus 1 d lambda by d. So for one wavelength you are getting one particular n1, second bright band or third bright band is forming, they will ask. So if you replace another wavelength, so you are getting there another bright band. At same point, two different bright bands are coinciding for two different wavelengths. So capital D, small d remains same. Distance yn is also remains same at same distance. At same distance, if you are doing with lambda 1, so let us assume second bright band is forming means if you're doing for lambda 2, some fourth bright band is forming there at same distance, at same vertical distance. At that time, what is the condition means? N1 lambda 1 is equal to N2 lambda 2. At that time, you have to use this formula. So, which formula we are using? Because fringe width does not depend on N, isn't it? D lambda by T. So, which formula you have to use? According to given data, you people are going to get idea if you practice problems. Understood? So, medium is depending on the surrounding medium also, fringe width is going to be changed. Like that, this one also will be changed because small lambda is there. So, shift in this fringe also, it will be affected. Okay, again, we will write lambda by mu w, we will write if you are using same wavelength. Different wavelength means we will use this formula like this, n1 lambda 1 equal to n2 lambda 2. See, we are doing only these two formulas, we are replacing always delta x equal to d sine theta. From here we got path difference. This is only changing time to time, place to place, or problem to problem. Next one is in between S1 and P. So we will place one thick plate, very thin of T, thickness T, and refractive index is mu. Then what is the new fringe pattern? How it is going to be shifted? They are going to ask. So at the time, this path difference. Did you remember path difference? Delta x. This delta x, how it is going to be changed whenever you are introducing one thin plate means so of refractive index mu. So mu minus 1 into T. This one we discussed in ray optics from 8 to means vacuum to medium if it is there, means if you are observing, and a medium within the medium if you are observing an object in vacuum. So the formula 1 minus 1 by mu into T, that shift formula. That shift formula you have to use here. Mu minus 1 into T. So our formula is according to this delta x equal to d sine theta is equal to n lambda. So what is delta x we got here? Mu minus 1 into T. Shift that is. Then C is d sine theta y by d is going to be mu minus 1 into t. If it is forming bright band, dark band, we will use that n lambda to n minus 1 lambda. Now y is equal to capital D into mu minus 1 into t by small t. This one we are going to write it as shift, isn't it? How much it is going to be shifted? How many number of fringes shifted they will ask. At the time, the shift we have to divide with beta. So what is beta we came to know? D into mu minus 1 into t by d. What is beta? D lambda by d. Then what is cancelling? You can see. What is cancelling? D by d, d by d. So mu minus 1 into t by lambda. This is number of fringes shifted. And some people will write delta y dash y naught, that is their wish. Number of fringes shifted formula is this. Whenever you are using one thick plate of refractive index mu, how much shift is going to be happen? This is the formula we are going to use, isn't it? It is going to increase, path difference increases by mu minus 1 into t. So this is for lateral shift. This is for how many number of fringes shifted. If they are using another one also here, so 2. So in this S1, S2, they have given two thick plates T1, mu1, T2, mu2. At the time, here we will take in place of mu minus 1 into T, mu1 minus 1 into T1 plus mu2 minus 1 into T2. So that one we have to take for this extra shift. That's all. 2 times you have to write. Capital D, small d is not changing. So we will see in problems how they are going to ask. So mainly these formulas, if you remember, you can solve any Young's double slit experiment problem. So mainly how much shift and how many number of fringes shifted. So if you call 2 to 3 times, you will remember this formula. So for this and this small change is there. Shift in terms of fringe width also they will ask sometimes. At the time, beta you have to write this side. So whenever you are writing this beta here, means beta is equal to what is the formula? D lambda by d. In place of d by d, In place of d by d, what we can write? Beta by lambda. Then shift formula, y is equal to, in place of d by d, so beta by lambda into mu minus 1 into t. Isn't it? Just in place of d by d, we replaced beta by lambda. This is also shift formula. So when shift is going to be happening, whenever you are introducing one thick or thin glass plate in one of the slit, isn't it? In front of one of the slit, if you are placing one thin glass plate. So if you are placing two, you have to write this equation two times. Mu1 minus 1 into T1 plus mu2 minus 1 into T2. So those we will see whenever we are solving problems. Just these are the main important equations on this Young's double slit experiment.